To calculate wire size, we will use a formula and NEC approved values. The formula is equals 2 times I times L divided by E times V. In this formula, it represents the ampacity or current carrying capacity of the wire in amps. I represents the current in amps. L represents the length of the wire in feet. E represents the voltage drop in volts. And V represents the voltage at the load in volts. The NEC specifies voltage drop limits for different types of circuits. For branch circuits, the voltage drop limit is 3%. For feeder circuits, the voltage drop limit is 5%. Here are the steps to calculate wire size. Firstly, determine the voltage drop limit. Use the NEC limit for the type of circuit. For this example, let's assume it's 3%. Secondly, calculate the voltage drop using the formula E equals V times voltage drop limit divided by 100. For example, E equals 400 volts times 3% divided by 100, which equals 12 volts. Thirdly, plug in the values into the ampacity formula. For example, I equals 2 times 235 amps times 3 feet divided by 12 volts times 400 volts. This simplifies to equals 3.125 amps. Then, round up to the nearest standard wire size. The closest standard wire size to 3.125 amps is #0, or 4/0. Based on the NEC formula, the appropriate wire size for this application is #0, or 4/0 American wire gauge. However, the 3/0 wire size with a rated ampacity of 260 amps may also be acceptable, as it is within the specified voltage drop limit of 3%. It's always recommended to consult with a qualified electrician for any electrical work to ensure safety and compliance with codes.